Welcome to Mr. Quinn Maths. Now in this video, again we're going to be focusing on completing the square, and we're going to be focusing on exam questions that have come up on the C1 papers. So our first question here, this one has to write the quadratic equation in the form as follows here. So basically completing the square for this. You can see there's 2 marks for this question. Should be easy marks for us. Now completing the square, that's going to give us x plus 3 all squared, and we're going to subtract the 9, and then we're adding the 17. Then simplify it then, so that gives us x plus 3 all squared Okay, here we have our first first exam question here. Feel free to pause this video now, have a read over the question and try it yourself. So in the first question we're asked to rewrite this quadratic equation in this form. So basically completing the square for it. There's 2 marks for it. It should be easy mark for us. It gives us x plus 3 all squared. We need to subtract the 9, and then we're adding on the 17. That then gives us x plus 3 all squared minus 9 plus 17 gives us plus 8. So we have a is equal to 3, and we've got our b there, which is equal to 8. In the second question, we're asked to state the coordinates of the turning point of this curve and identify it as a maximum or a minimum. Now, having a look at this quadratic equation, we know it's going to be a U-shaped curve. So it's going to be a minimum point, first of all. Right, so we need to make sure we write out our equation here. We have our x plus 3 all squared plus 8. Now it's going to be equal to y. If we put this equation equal to 0, then we're able to tell what the minimum point is. So we've got x plus 3 all squared plus 8 is equal to 0. Therefore our minimum point is going to be 8 at x is equal to, let's look at what the x value will be. Now, to make this here 0, and as a result give us make this equation equal our minimum point, the value of x here must be minus 3. So the minimum point is minus 3, 8. In this question we have to state the range of values of x for which the value of y is increasing. Now we know the midpoint here is minus 3, 8. And we know it's going to be a U-shaped curve, so the curve is going to look something like this here. Might be a good idea to do this in exam, to be sketch to just visualize the curve. This point here is minus 3, 8, and they're asking for the range of values for x for which the y value is increasing. This y value is increasing. So basically when x is greater than this minus 3, you can see that the y value is increasing. So the range of values for x for which the y value is increasing is when x is greater than minus 3. The next question we have to find the corresponding range of values for y. The range of values for y is going from here right the way up here. So this minimum value, is 8. So it's going from 8 right the way up to basically infinity. So y is going to be greater than 8. Alright, here we have another question here, another past paper question. Feel free to pause the video, have a wee read over it and try it yourself. Okay, the first question asks us to express this quadratic equation in this form. Okay, 3 marks for this one. So we must do is factorize the equation here. Bring 2 outside the brackets with 2 upon x squared minus 4x plus 1/2. Now we can complete the square for the x squared minus 4x. This then gives us 2 upon x minus 2 all squared. And then we must subtract the 4 then. So it's equal to x squared minus 4x. And then we're going to add on our half. So expand it, or simplify this now. We have minus 4 plus the half, which is minus 3.5. So we've got 2 upon x minus 2 all squared minus 3.5, which is 2 upon x minus 2 all squared minus 7. So now we have it written the form as requested here. We know that a is equal to 2, b is equal to 2, and c is equal to 7. Now there's another way we could have done this. 2x squared minus 8x plus 1. Just factorize this first 2 terms here, bring a 2 out of it. So we have 2 upon x squared minus 4x. And then we add another 1. So complete the square for the bracket. So we've got 2 upon x minus 2 all squared. Just put a square bracket around this. And then we're going to take away 4. Add another 1. This then gives us 2 upon x minus 2 all squared minus 8. And then we're plus another 1 here, which gives us the same answer. X minus 2 all squared minus 8 plus a 7 is minus 7. So we've still got our a value equal to 2, b equal to 2, and c is equal to 7. Okay, here we have another. Okay, here we have another past paper question. Feel free to pause this video now and have a go at it yourself. The first question asks us to express this quadratic equation in this form here. So completing the square for this quadratic equation. Okay, the first thing we're going to do is factorize the first 2 terms here. Let's bring the 2 outside the brackets. 2 upon our x squared minus 4x plus our 1. And then we can complete the square for this bracket here. That gives us 2 upon x minus 2 all squared minus 4. You have to subtract the 4 for it to be equal to this. And then we're adding our 1. So multiply out the brackets here, multiply the 2 into the brackets here. So we got 2 upon x minus 2 all squared minus 8. And remember to add on the 1 here, so that gives us 2 upon x minus 2 all squared minus 8 plus 7, which is, or minus 8 plus 1 gives us minus 7. So now we have this quadratic equation in the form displayed here. Second question, we have to state the minimum value for this quadratic equation and the value of x at which it occurs. So remember that the minimum value is basically our number here. So the minimum value of y is going to be equal to minus 7, and that is when this is going to be equal to 0. So what value of x is going to make this equal to 0? Well, x equal to 2. So what? X equal to 2. So the point, the minimum point, is going to be 2 minus 7. So that one should have been a fairly straightforward question for 5 marks overall. The thing to be careful about is completing the square when you have a quadratic equation with a number greater than 1 in front of the x squared here. You can sometimes run into trouble doing that.